Thanks, Jim. Thank you, everyone, for attending. Apologies if I'm going to be speaking a bit fast. I'm trying to get through a 30-minute presentation in 10 minutes. For those who aren't aware, Amero is a metal 3D printing company. We were spun out of Monash University through their division called MCAM, which is Monash Centre for Additive Manufacturing. And that centre is actually the world's leading institute for metal 3D printing. They've got 50 full-time researchers working every day to make 3D printing better in metals. And we're co-located with them. So that gives us access to those 50 scientists along with our own R&D staff. That means that Amero has the largest R&D team in the world in metal 3D printing, which affords us some really nice IP and some new unique positioning in the market. Next slide, please. This is the disclaimer. I'll just let you look at that in your own time. But about Amero, so we were established in 2013, as I said, from Monash University. We specialise in the areas of defence, aviation, aerospace and industrial tooling. We've got a lot of world's firsts. We 3D printed the world's first jet engine, the world's first aerospike rocket motor, which you see on the right there. That's a cutaway of that. The world's first flying hot parts in the internal hot parts of the turbine engines. They're flying in military aircraft today. So we're respected by those in the know, the big defence and aviation companies, and they come to us when they want to solve their problems. We have operations in Australia, in Melbourne and Australia, and also in California and USA, and they're all manufacturing operations. Next slide, please. So just some investment highlights. The industry, if you're not invested into the 3D printing sector, then you probably should be. It's the fastest growing sector on Earth. It's growing at 60% CAGRs year on year. Last year did $12 billion turnover. It'll do 120 billion turnover within just another 4 years. So we'd like you to invest in Amero, but if not, you should be investing in the industry. We've got a lot of leading technologies. We've got a series of machines, 3D printers, which I'll show you in a little while. They're the world's fastest and most cost-efficient metal 3D printers. We also have leading technologies in producing and manufacturing the metal powders that go in these machines. They're called gas atomizers. And our new atomization technology enables us to make metal powders, and particularly titanium, at under half the cost of anyone else in the world, which is really positioning us as a global leader. We also have some global expertise on our board. For example, on the powder manufacturing, Dr. James Sears. He is the world expert in gas atomization and creating these metal powders. He set up GE's powder facility, Pratt & Whitney's, Carpenter's, who are the largest titanium manufacturer in the world. So he is recognised as the world authority, and now he works full-time for us. And he's the one that's developed this new technology, enabling us to make powder at half the price of everyone else. We also have an amazing board and board advisors, including the ex-Secretary of Defence of the United States, Patrick Shanahan. Also the ex-Secretary of Defence here in Australia, Christopher Pine, and many other really high-level leaders who strategise together to position us as a leader in defence, aviation, aerospace and tooling. Scale and profitability, well, we're moving now from working on R&D projects, proving up the components for these large companies, and we do with 6 of the top 10 defence companies on Earth. And now we're moving into the manufacturing and the profitable part of the business, which is quite exciting. We have strong partnerships. We mentioned Boeing and Rio Tinto and Raytheon and many others. But also on the research side, not just Monash University, who are our 3rd largest shareholder, but also Adelaide University, who are a top 10 shareholder, and CSIRO, who are just across the road from us. And we work with them collaboratively on a lot of projects. In fact, our CEO, Barry Finnan, used to head up the metals divisions at CSIRO. Next slide, please. So what is additive manufacturing? Well, 3D printing. So what happens with metal 3D printing is a layer of powder is laid down on a plate, and then a laser comes in and lays lasers and consolidates the metal in where you're trying to build up metal, and then another layer, and it just builds it up slowly until you have a complete part. But what it enables you to do is to make things that have never been able to be made before. That's a cutaway of a Bell rocket engine there, and you can see the ladder structure in underneath. You can't make that any other way. So metal 3D printing enables you to make things that haven't been able to be made before, but also to consolidate parts. So you might now take 20 components and you just print them all in one, which saves weight and makes it safer because you don't have all of those interfaces, those 19 interfaces over 20 parts, which are risk areas. Next slide, please. So some of our key projects, I mentioned the titanium powder plant. So that's being manufactured in Europe at the moment, and we've just signed heads of agreement for a new lease, and I'll show you that facility in a little while. But this just one gas atomizer is going to produce $40 million worth of revenue. We just upgraded our earnings for that from 30 million to 40.8 million. And that's a very, very profitable exercise. We announced at our AGM that we'll be able to pay that capital cost back from profits in under 6 months. So that gives you an idea of how profitable our titanium plant's going to be, which is really just a license to scale up. We'll be able to debt fund our scaling up, and I'll talk a little bit about that in a minute. We're also working on the world's largest centre of excellence for metal 3D printing in the Middle East. We'll be building that. That's a $100 million facility. It'll be paid for by one of our defence clients on behalf of the Middle Eastern country through a defence offset deal. Fletcher's Insulation, they make pink bats that go in your walls and your ceilings, glass wool. So they licensed that off of Owens Corning in the US, and a Fortune 500 company, and they're the largest manufacturer of glass wool in the world. So when you make glass wool, they use a tool that's a round tool about yay big. It's donut shaped. They pour molten glass on the top, and it spins out through tens of thousands of holes in the walls of that. And these tools cost about $4 grand a pop, but they only last 4 days. And they've got hundreds of these machines around the world. And so we believe this is the world's largest consumable tooling project. And we've developed a way with them, in collaborating with them, to make a tool that lasts longer and is cheaper. And so we're very excited about that project, and we'll have a heads of agreement signed off on that very soon. Boeing is one of our clients, mentioned earlier. We built a facility in El Segundo, which is called Aviation Alley in California. And we are manufacturing parts for satellites and various other programs that they have. And our plan with them is to 10x that facility over the next year or two. Gilmore Space, we announced recently, awesome Australian space company doing amazing things, really pushing the envelope. So we've announced a $1.7 million contract with them to make components for their rockets. Next slide, please. These are our machines, ranging from the little SP100 up to the brand new SP800, which is in alpha testing at the moment and will be released later next year. That's the largest metal 3D printing machine on Earth, about 30% larger than the next biggest, which is GE's offering of the X-Line 2000. So we'll have the largest range out of any company in the world, which is exciting for us. Next slide, please. I won't spend too long on this because it's quite wordy, but short term, I've already gone through the opportunities. Medium term, which is really only 2 years, we'll be scaling out those powder operations. So as I mentioned, one gas atomizer can produce $40 million worth of revenues. We want to 5 to 10x that in the very short term, medium term, 2+ years, which will really change the dynamics of our revenues. Next slide, please. So in short, because I'm running out of time, we're constructing the world's most efficient titanium powder plant, making powder under half the price of everyone else. Supplying titanium powder to our defence clients around the world because they don't want to buy from China and Russia anymore. They want to buy from allied nations. So this will be Australian titanium resources turned into powder. We also have a binding heads of agreement coming for that tooling project, the largest tooling project in the world. We're also building the largest centre of excellence in the world in the Middle East. with one of our defence partners. I've talked about buying. One thing I haven't mentioned is our proprietary alloys. So we've got some patented new alloys, one called Hot Al, which is basically 30% stronger than the incumbent aluminium and has double the operating temperature, which means it can be used in hot parts of turbine engines where maybe nickel-based super alloys were used at 3 times the weight and much, much more expensive. So we're really excited about that one. And we have a new titanium alloy called Beta-Tite, which has 20 to 25% stronger shear strength. But the real main takeaway from that one is that it's got 5 times the fatigue life. So I don't know if you've ever sat on a plane, you've looked out the window at the wing and you see hundreds, thousands, in fact, rivets. So those rivets are all made out of titanium, and fatigue is the thing, fatigue life is the thing that they're after. Those current rivets, ours has 5 times the fatigue life. So that's a multi-billion-dollar market in itself. So we're really excited about that. I think I'll stop there. Oh, actually, just on the right there, those photos, you'll see the white section of that building, that's existing. That's our new facility that we're leasing. And then the light blue section, which is the tall section below, that's being built to cater for our new titanium gas atomization facility. And so we'll be moving in there next year, which we're really excited about. Thanks, Tim.
Thanks, Stuart. Bang on time. A couple of, for those who don't know the business, I mean, it's an impressive presentation, some big names in terms of contracts, but your share price has been pretty weak over the last 12 months. But what's the reasons for that?
Yeah, well, we're a manufacturing company, and like a lot of manufacturing companies, COVID's really hit us badly. We make machines, and we rely on components being made by other manufacturers, and they're having the same problems in logistics as well. I mean, you're booking 6 months in advance now to get a shipping container. It's hard to get suppliers to make for the raw materials to make the components, for then us to buy the components to get them in. So it really has pushed things back. With regards to our Middle Eastern project, we've had it for COVID, we've had our trip cancelled 5 times. So we just can't get over there to pick our new facility to be able to build that $100 million centre of excellence. So it really has been frustrating. We've been pushed back around about 6 months, so we haven't been able to meet those expected timelines. And I think people just want to see the revenues. But I think you can see from what I've shown in this presentation that we're at the pointy end of all of those contracts, and it is an exciting time for our company.
And you've obviously got an impressive board there in terms of dealing with some of the big names in defence. Can you talk us through the process of how long a contract takes to negotiate, be signed? You mentioned a lot of R&D. Who's kind of funding that R&D? And then how long is a contract and kind of what's it worth on average?
Yeah, well, look, I'll use the tooling project as an example. That was about $100,000 spent by our client to get us to develop a process for them, which was going to be able to 3D print that tool for them. Now, in all, that tooling contract is worth about $350 million a year. That's what they're spending a year on that tool globally. So it's a huge opportunity for us. And it's taken around about 6 months to develop the new alloy, because we've come up with our own alloy specification, which is 22% harder. 32% harder and 22% more strength under heat. So, that company's been working for 30 years to make that as hard as possible. And then through a 3D manufacturing process, we've been able to make it better, harder, and last longer. And then that will result in us slowly ramping up and taking over as much of that contract as we can.
And with your new facilities there, do you have a kind of full queue of customers ready to kind of utilise those facilities when you're at capacity?
Yeah, absolutely. And I mentioned our new SP800 that's coming out. And we've got multiple of the defence companies wanting to make large components, and they just can't make them at the moment. Because some of the other additive manufacturing technologies that you may have seen aren't qualified for aerospace and defence, whereas selective laser melting, which is what we deal in, is the most certified process for all of those applications. And so this will be the largest machine. So, we're talking about making large rocket components and fuel sections for canisters and a whole heap of very large parts that have never been able to be made before. So there's a lot of excitement around that.
And news flow into 2022, what can, you know, potential new investors and existing shareholders look forward to?
Yeah, well, I think the expansion of the powder plant's really exciting. As I said, the one atomizer is producing $40 million worth of revenue at high profits, and we really want to scale that out. So we'll be releasing what our plan is to 5 and 10x that. We can take 3 gas atomizers in that current new facility you see on that slide, but we are planning with our defence primes on investment to be able to scale that out further. So that's probably the single one most exciting one.